So welcome back. This is the second video that discusses applications of the migration model. So remember what the migration model says. We have a situation where customer inactivity during some period doesn't mean that a relationship is over. So think retailing, travel, not-for-profits, and so forth. With the migration model, we define some number of states and assume that customers migrate between these states over time. So in the previous video, we talked about two fairly simple models. We started out with the buy, no buy model. In the buy, no buy model, there are exactly two states. One is where the customer is active in that period, the buyers, and the other state is where the customer is inactive, the non-buyers. And we derived a number of results on this. So we showed how to use matrix notation and results from Markov chain theory to be able to work out a closed form expression for lifetime value. We also showed how the buy, no buy model could be a generalization of the simple retention model that we used for the gone for good situation. Now there's a big problem with the buy, no buy model. The problem is that within the non-buyers and probably within the buyers as well, there's a lot of heterogeneity. So a customer who has been inactive for 1 month, so as a non-buyer and has just entered that state, is very different than a customer who has been inactive for, say, 3 years. The two will have very different probabilities of buying again. So one way to handle this was with the recency model. So the recency model allowed for additional state. So if I've been inactive for 4 years, the probability that I come back and buy again can be much lower if we allow a long lapsed state in our model versus someone who had only been inactive for, say, a month. So in this video, we're going to take this a step further. We know that recency is by far one of the most important predictors in retail settings, but another very important predictor is frequency. So frequency is how many times has the customer purchased in the past. So it should be fairly plausible to you that if I'm a first-time buyer, I've only bought from you once, the chance of getting another order will be substantially lower than if I'm a habitual buyer and I bought, say, 20 times from you in the past. The recency-only model would treat those two customers the same, and that's not a good idea. The way we're going to handle this is to bring frequency into it. Before I get into this model, let me just mention there's still more heterogeneity, which comes from monetary value. What you're going to find is that what is often the case is that people who have large orders in the past tend to have large orders in the future, while people who place small orders in the past tend to place small orders in the future. So we know that the monetary value, or the amount that customers spend per order or per donation, per trip if it's an airliner, is predictive of the future. So often we would account for all three of those factors, the recency, the frequency, as well as the monetary value. So I have data from a retailer, and I decided to define a recency frequency migration model. So I have 7 states. Let's go sketch out the state diagram. So state number 1 is up here. So let's just put 1 up here. And this is the state where recency is less than 1 year. And frequency, I'm going to define frequency a little differently in this problem. So F is equal to the number of years with an order. This will simplify the model a little bit, but still get the point across. So F equals 1. So you can think of these as customers who bought within the past year for the first time. So we can think of these as new customers. This is the new customer segment. Well, segment 2, or state 2, is going to be customers who are recent, less than a year, but their frequency is greater than 1. So we can think of this state as being recent multi-time buyers. So these are your loyal customers. Now we could have additional frequency states if we wanted to, but for the purpose of this example, let's not do that. The third state is going to be customers who've been lapsed for 1 year and have only purchased once. So let's go add them to my diagram. So this is state 3, 1 less than or equal to recency less than 2 years, and we have one-time buyers. Let's go add state 4. State 4 is going to be 1 less than or equal to R less than 2, F greater than 1. Now we can start drawing some arrows in. If I am a first-time buyer and I just started buying from you within the past year, what can happen to me next? Well, clearly, if I buy again, I transition to state 2. Here I've purchased within a year, and now I've purchased in more than 1 year, so my frequency is greater than 1. I'm going to call this probability P1. Now what could happen to me if I don't buy? Well, if I don't buy, then I transition into the state where I'm 1 year lapsed, but my frequency is still 1. I'm a one-time buyer. This is going to happen with probability 1 minus P1. Now let's think about state 2. If a person in state 2 buys again, where do they go? Well, they come back to the same state again, because if I purchase twice and then I purchase again, I'm now a 3-time buyer and I'm completely recent. We're going to call this probability P2. So the probability that someone in state, maybe I should write this down. Let P sub I equal the probability that a customer in state I buys again. Well, what happens to me if I don't purchase? If I'm one of these recent multi-timers and I don't buy? Well, the answer is I become a 1 year lapsed multi-time buyer. And this is going to happen with probability 1 minus P2. What about state 3? If someone in state 3 buys, they transition to being a multi-timer who has purchased within the past year. So that's P3. What happens if they don't buy? Well, let's go back and look at this. State 5, we could have broken this out by frequency, but for the sake of simplicity, I'm just going to put all the frequencies together. So we have a new state out here, state 5. So this state is 2 less than or equal to R less than 3. So they've been inactive between 2 and 3 years. Frequency can be anything you want. So a customer who's in this state who decides not to buy transitions into state 5 with probability 1 minus P3. Likewise, if I'm in state 4 and I buy again, I come back to state 2. That's going to happen with probability P4. If I decide not to buy, I transition into state 5 with probability 1 minus P4. What comes next? We have state 6 and state 7. I might as well go write both of those in. So here's state 6. This is going to be 3 less than or equal to R less than 4. And state 7 is out here where R is greater than or equal to 4. So if I'm in state 5 and I decide to buy again, what happens to me? Well, what happens is I come back to state 2, and that happens with probability P5. If I decide not to buy, I'm going to transition to state 6. That's going to happen with probability 1 minus P5. If I'm in state 6 and I buy again, I come back and I'm in state 2 again. That happens with probability P6. Otherwise, I migrate to state 7 with probability 1 minus P6. Finally, what happens to me if I'm in P7 and I buy again? Well, I come back to state 2. That's going to happen with probability P7. Otherwise, what happens? Well, I get stuck in state 7. I come back to state 7. That happens with probability 1 minus P7. So this is our state diagram. I'd like to now show how we can estimate this using some real data. Let's say that this is the last day in 2004. I know everything that happened during the year 2004. In order to estimate my probabilities, I'm going to turn the clock back, and I can look at what did my database look like 1 year ago. And so this is before January 1st, 2004, or the last day of 2003 is another way to think of this. Well, I can simply go off and count the number of customers that I have in each segment as of December 31st, 2003. So I would have to define a variable that identifies your segment or state and then just run a count on it. And so here we have our counts, and we have the total number of customers in this database, which is about 92,000. Well, the next thing I'm going to do is look at how those customers behaved during 2004, so between January 1st and December 31st, 2004. So it would be easy enough to count the number of buyers. So this is something I can easily count from my database. I could also sum the total amount that customers in that state bought. So with one query, I can get the counts and the sums of the buyers and the dollar amounts. Once I have the buyers, I can simply divide the number of buyers by the number of customers and get, well, roughly 15% of these new customers, that is, new customers during 2003, bought again in 2004. Whereas multi-time customers, you're going to see buy at a rate that's about 40%. And so the fact that these two percentages are very different makes the point for why we need to consider frequency as well as just recency. Because notice, these two segments have exactly the same recency values, but the buy rates are completely different. If we come down to 1 year lapsed, we end up with a very similar story where one-time buyers who are 1 year lapsed activate at a rate of about 5%, whereas those who are multi-timers activated at a rate around 14%. So that's why we need to account for frequency. We need to do one more thing, which is to compute how much revenue we think we're going to make from these customers. So if I take the total dollars divided by the number of buyers, I'm going to get dollars per buyer, or you can think of this as, for an active customer, how much does this customer spend? Now, what you'll see here is something that often happens where the dollars per buyer is fairly consistent across recency and frequency segments. The amount that you spend is fairly independent of how recent you are or how frequently you've purchased. This is truly a new dimension. We do see, however, that customers that are long lapsed, so if they've been inactive for 3 or more years, they tend to spend a bit less. Overall, the amount per buyer is about $48. Now, the basic Pfeiffer-Caraway model only allows for one monetary value, so we might just use that $48. Or we could have a slightly more complicated model where we allow different dollar amounts for each of our states. Well, now that we have P and we have our value vector, we could go off and use the matrix stuff, and that would be completely fine. And what you're going to see is that on the next slide, I actually give you the matrix form. What I'd now like to do, though, is something that I'm slightly embarrassed by. I'm going to use Excel. The reason for that is this model has been used for decades by financial people for various calculations. They don't really call it the migration model. They just, it's a spreadsheet model, and they do it in spreadsheets often. So I think it's worth seeing the spreadsheet version of this. Here's where we're at. I went off and I did my database counts. I did my counts of the buyers. I did my sum of the dollar amounts. Now let's set this up so that we can roll this out into the future. So the first thing I'm going to do is put in the period number. Now the period number here is going to be whatever the previous period is plus 1. So start out in 2003. This is going to be 2004. Let's go compute our buy rates. So the buy rates are going to be take the number of buyers, divide by the number of customers, and we'll copy it down. Let's get dollars per buyer now. So dollars per buyer will be the total dollars divide by the number of buyers. That's why it's called dollars per buyer. We'll copy this down. And I could actually copy it one step further to get the total. So we're at about $48. Now I entered in an M of 48, but I could just as easily use different numbers for each time, and that's totally fine. I have another cell up here which is something we haven't talked about yet, but maybe I want to acquire new customers along the way. I'm just going to set that to 0 right now, assuming we're not going to acquire any new customers, but you can guess in a few minutes we will start acquiring new customers. The whole idea is I want to have a new block that I can copy down for what's going to happen in the next year and the year after and maybe the year after. For practical business planning purposes, going a couple years out is probably good enough, as opposed to what we're doing with our perpetuity formula that takes this out to infinity. The period here is going to be whatever the previous period was, and then this will be whatever this is plus 1 year. Now we're going to know what happened at the end of 2004, and I'm going to use that to project what's going to happen in 2005. Let's just start thinking about this. How many customers do I have in the recent one-time bin? Let's go take a look at my document camera. How do I get into this cell? And the answer is, the only way I can get into this cell is if I'm a new customer. And since we're not acquiring any new customers, we're not adding anything to the database here. But just to allow for this, I'm going to set this equal to $1. So I've kind of set a parameter up here that we could play with. We could increase the number of customers that we acquire in the given period. So how many recent multi-time buyers do I have? The answer to this is easy. It's simply this number. This is the number of people who bought from me in 2004. All right, well, let's move on. How many one-time, one-year lapse customers do I have? So in other words, how many customers do I have in here? Well, the answer is all the customers who were in state 1 and didn't buy go to state 3. So it's just the difference between the number of customers that I started with in state 1 and the number who bought. And so we got about 8,000 something customers in that segment. What about state 4? Well, I think the state diagram really helps us here. How do I get it to be in state 4? The answer is the only way I can come in is from state 2. So let's take all the people that we started with in state 2 less those who bought in the previous year. So we end up with about 4,621 customers in state 4. Now what about state 5? How do I get into state 5? Well, I'm either in state 3 or 4 and I didn't buy. So all those in those two states who didn't buy transition into state 5. Let's go take the number of customers who were in state 3 plus the number of customers who were in state 4 minus the buyers, because the buyers we've already accounted for up here. So that number, the buyers, we've already taken out. We've got to do state 6. How do I get to be in state 6? The answer is I was in state 5 and I didn't buy. So we're going to go take all those in state 5 less those who bought, and I get my count. What about state 7? Well, how do I get to be in state 7? Well, there's two ways. Either I'm in state 6 or I'm in state 7 and I didn't buy. So we're going to have a slightly more complicated situation where I have to add those customers to those customers, subtract off the buyers, and we're done. Now, if I did this right, I should have exactly the same number of customers that I had before. So let's add these up, and notice this number exactly equals the previous number. It's just that they've been shuffled around into different customers. Now we're going to start doing some forecasting. All I've done up to this point is just count customers. Well, I'm going to assume that the buy rates hold consistent in the future. That's what our Markov chain assumption says. So I'm just going to copy these things down. So notice all of these are exactly what they were before. When it comes to dollars per buyer, I am going to set this equal to $1. Using the spreadsheet model, it's extremely easy to see how I could just copy these numbers down instead. So the spreadsheet model may be a little bit easier. Let's go compute the number of buyers. So the number of buyers will be, take the number of customers that you started with and multiply by the fraction who you expect to buy. And so we started with none, 14.7% of those none buy. And so I don't have any buyers in state 1. Here are my other buyers. Now I also need to sum these, so let's just go copy that sum formula over. So maybe I did that too quickly. We have the sum right here. What about the total dollars? Well, the total dollars will equal the number of buyers that I have times whatever we make per buyer. So I can copy that across. Let's go get our sums. So this is going to be the sum of all this. So this is going to be the total revenue that I expect to make in 2005. One more thing. We could do some discounting because we don't make this money immediately. So if I want to discount this, I would take this number, divide that by 1 plus my discount rate. So my discount rate I stored up here in $1. And let's say that on the average I have to wait a half a year to get these. That may not be realistic if I have a lot of Christmas orders, then I'd have to wait a bit longer. But the point is, I'm going to take 2005 minus, and let's say this is the end of 2004. So this is going to be 2004, and I'm going to add a half, so assuming that we just have to wait a half a year for this. So discounted, this is worth about $281,000. So we're now set up to start copying this. Let's go do that. I am going to copy this. If I paste it one cell below here, notice that we have a forecast for what's going to happen in 2006. We can do the same, paste it again. We have a forecast for 2007. Maybe we're interested in going out about 5 years. And so now we have our very simple spreadsheet forecasting model. Now, if you wanted to do this with matrix notation, let's go over to my document camera for a second. And remember that P is the transition matrix. So what comes into P is the current state. What comes out of P is where I am next period. So that gives me the probability distribution for next period. And if you remember the formula that we had last time, if I take n times this, that's going to give me the expected counts that I have 1 period out. So this is going to be the expected state counts in 1 period. Now, if you remember, p squared is where I'm going to be 2 periods from now. So if I just take the number of customers, multiply it by p squared, this is going to be the expected state counts 2 periods into the future. N transpose p cubed would be 3 years into the future, and so forth. If you want the value of this, you multiply by v. So remember, my value vector is equal to the value vector, which is the amount of revenue from state I. So if we really want to do this with matrix notation, we'll set up our initial counts. So these initial counts are exactly what I computed when I ran my query. Then my value vector is going to look like this. States 1 and 2 have active buyers. If I have a customer who moves into state 1 or 2, I get $48. Otherwise, I get 0. So we could make this more complicated by accounting for marketing costs, but let's not do that right now. So you have the R code on the next page, but let's go run this live. So I've defined my N matrix. I'm just going to look at the number of buyers, so that came right out of my SQL query. Here's my V. So let's just go look at what these are. N, X, and V. Now I can compute my transition matrix. There's not a simple way to do this. You can study the code if you're interested. What I've done gives me the correct transition matrix that we computed back here in the course packet. So I'm now going to define a matrix that I'll just call PT, which will be P to the T. Then I'm going to define a matrix that I can use to store the answer, and also another matrix to store the revenues. Now I've set up a little for loop. What the for loop is going to do is it will keep multiplying PT by P. So we're going to start out with the identity matrix. The first time through, this will just give me a one-step transition matrix. The second time through this loop, we're going to have P squared, then P cubed, and so forth. This expression is going to give me the counts of customers in each cell at the end of that time period. Then let's go compute the revenue, just as we discussed. Here we have the number of customers that we expect in each state and the revenues. So let's just go take a look at this. 324,098, and that's exactly what we had here. 324,098. Let's go one more period out. 286,874. So it looks like this thing does exactly what we wanted it to do. So for practical planning purposes, taking this out, say 3 or 5 years, is probably plenty. Let's just add up the discounted revenue. We can think of this as long-term value as opposed to lifetime value because it's only a couple years in the future. Let's take I-24. We'll assign this as I-24 through, say, I-100. And so this database, as is worth about $1 million. Now, this is very powerful because we could start to do some what-if analyses. Let's say we did something to increase the buy rate among our best customers. So perhaps we sent them additional touch points. Maybe we had a personalized call or something that contacted them. This buy rate would then increase. So because of this touch point, let's say it increases from 40% up to, say, 44%. And you can see the effect on your discounted revenue. Alternatively, maybe I should spend more effort trying to win back these customers. So I could change this, I could do more to reactivate my lapsed customers, and maybe I increase this to 15%, and we can see the effect that it has on the discounted revenue a couple of years out. I'll just undo that. Another thing that I could do is to try to cross-sell or upsell customers. So if I built a recommender system that would do a better job of cross-selling customers, what would happen is the dollars that I got per buyer would increase. So what would happen if I took this from $48 to, say, $55? And you can see the effect on your long-term cash flows. My point with this is it's a very powerful tool that allows for all sorts of what-if analyses. If I spent more on retention, what would happen? If I spent more on cross-selling, what would happen? The one thing that we haven't really addressed is what would happen if I spent more money on acquisition? So what you'll notice if you stare at this matrix a little bit is that customers start gravitating towards this long-lapsed segment 7. So we started out with just, say, 32,000 customers. I took this out 9 years, and you can see we're up to about 80-some thousand customers there. So what happens is all of these fresh customers become stale, and they gravitate towards the long-lapsed group. And what do we know about the long-lapsed group? Well, they're not very likely to buy again. So notice they only reactivate with a probability of 2.5%, whereas some of these other groups are coming back at rates of 40%. The problem that we have has often been described as the leaky bucket problem. So the leaky bucket problem is where all of your customers are like water in a bucket, but there's a hole in the bucket where water is leaking out. So those are customers who are leaving you, and they're probably never going to come back. Yeah, there is some probability to come back, but it's tiny. So in order to avoid this, you either make the leak smaller, so you do a better job of keeping customers in these top states, or what you do is you start adding water to the top of the bucket. And so adding water to the top of the bucket is acquisition. So we could spend money to acquire new customers. We could advertise to attract brand new customers to add each year. If we could acquire the same number of customers that we did last year, so let's just go enter that in, 10,360, what you'll see is that now, instead of the business shrinking, the business is actually growing. So the number of customers that you have active in a year grows, the revenue amounts grow, and you can see that had a substantial impact on the projected revenues. And that had a major impact on projected revenues 5 years out. Of course, what's missing from all of this are the costs. So what are the costs of acquiring these customers versus the costs of doing a better job of retaining the customers that you have? And we don't know that in this example, but that would be the next type of information that you'd want to add to this analysis. I wanted to show one more example of how you can apply this migration model in a different setting. So the setting here is local newspapers. Now this diagram is actually a state diagram where each of these blue figures represent states. Now what we have here is really an illustration of something called the purchase funnel. In the case of a newspaper, what a lot of them try to do is gather the names of registered users. So they attract people who sign up for, say, a daily newsletter that gives them the briefing. And they begin in this segment. So they have to spend, you can think of there being a spigot that they can turn on and acquire additional registered users. You can think of that newsletter as a sample. So customers are trying your product through the newsletter, and hopefully, if they like your product, they go on to buy it. So the news organization, once you sign up for that newsletter, will actively start trying to convert you into a new subscriber. So new subscribers are people who have given you their credit card and said, you can charge me a certain amount each month. Now what tends to happen is that new subscribers get offered an introductory rate So the first month, maybe you only pay $1, whereas on later months you have to pay $15 a month for the news subscription. So you can imagine that your churn rates are going to be much higher once you become an established subscriber and you're paying much more money than when you're in this trial period. Sometimes news organizations will just acquire customers without them being registered users first. So you could think about two different spigots that you can use to add water to the system. You can either add them through registered users or through these trial offers. Now, once I'm a new subscriber, what could happen to me? Well, I could become an established subscriber, where an established subscriber is paying you the full rate and they're reading you regularly. Another state is what I'm going to call at-risk subscribers. At-risk subscribers are paying you full rate, but they're very likely to churn because they're not using your product. So think about subscribing to Netflix where you weren't watching any movies. Well, Netflix should be very worried that they're going to lose you as a customer. Likewise, if I have a subscription to a newspaper and I never read it, I'm going to be very much at risk of churning, and you can show that with churn models. Now, if I'm an at-risk subscriber, what can happen to me? Well, there's some good things that could happen to me. I could come back and start reading you again, or I could become a churn subscriber. If I'm a churn subscriber, I can stay a churn subscriber, or hopefully, or you could win me back, and we're going to call that the win-back rate. This is actually a state diagram. It'd be very easy to count the number of customers that you have in any one of these states in some month and see where they go the next month. Then you can estimate all of these different transition probabilities. So each one of these arrows corresponds to a transition probability. You'd like to encourage all the green ones. You'd like to discourage all the red ones. You can also add new customers to the system with these big green arrows. So in covering these 4 examples, I hope that you have a better sense of the flexibility of this migration model. So you can define your segments in a lot of different ways and use them as a powerful forecasting tool for planning in the future.